Okay, today my topic of discussion is single slit diffraction. In my earlier lecture, I have give some statement and I derive the Kirchhoff-Fresnel diffraction theory and how this diffraction theory is applicable to rectangular slit that I have already discussed. Uh, so, in this class, another Fraunhofer type of diffraction, that is single slit diffraction, is going to be discussed. Say this is a single slit. There is one opening on the slit, that is S1 S2, and some parallel monochromatic ray of plane wavefront, that is AB, that are coming to incident on this S1 S2 slit, and these rays are the parallel rays. They are just incident at an angle theta with the normal that are drawn on the plane wave, this AB line. Okay. Now the wavelets that are traveling at an angle with the normal are focused at point Q. After it is being they are being converged by this convex lens, right? So the secondary wavelets that are generated at this point O have amplitude a e to the power I omega t. Okay, as this is the plane wavefront. Now, what are the phase difference between two rays that are coming, one from O and another is coming from this point P? That is just the difference of the path, that is Pn, that are covered by this PQ ray with respect to OQ rays. Okay, so that amount path difference is basically twice pi by lambda times perpendicular, that is the excess distance covered by this ray, that is Pn. So if you consider that this length is x, this PO, then this will be twice pi by lambda x into sine theta. So Pn will be twice pi by lambda x into sine theta, and I call this as L into S x, where L is equal to twice pi by lambda into sine theta, which is solely depend on theta and obviously the wavelength of incident light, that is lambda. Now, according to Fresnel-Kirchhoff's theory, if a light ray is propagating, then at Q the diffraction due to elemental length dx, this dx for elemental length dx, the diffraction will be proportional to this phase difference e to the power I omega t minus Lx, where Lx is the path difference, phase difference due to excess amount of path covered by the ray, that is Pn. So the resultant disturbance at Q will be due to this dx length, elemental length, will be C, A is the amplitude, times dx times e to the power I omega t minus Lx, where A, small a, represent the width of the slit. Now, as this O is the origin or the center of this slit, there will be plus a by 2 distance from this point to S1, and this distance will be a by 2. So the point coordinate may be I choose as S of S2 as minus a by 2. So coordinate of S1 is plus a by 2 and this is minus a by 2. So I have to make an integration from minus a by 2 to plus a by 2 if I want to calculate the total contribution of the slit, or the total contribution of the rays that are coming and that are converge at point Q, and those rays which are going to produce some diffraction pattern at point Q. Okay, so that will be minus a by 2 to plus a by 2. Now if you integrate the whole thing, the integration runs on dx only. So e to the power I omega t remain constant at that time. Okay, so the integration c a e to the power I omega t, I bring it out from integration because they represent as constant, and the integration are done only on this x variable. Okay, now the integration, if we calculate, it will be e to the power I lx divided by minus il. So that will be ca e to the power I omega t e to the power minus I L a by 2 minus e to the power I L a by 2 divided by all the IL. Now this term will give me sine LA by 2, and this will be L by 2 because this will be I sine L by 2, so I will cancel each other, so that will be sine LA by 2 divided by LA by 2 into A into the power I omega t. Now the intensity is just the disturbance into its complex conjugate, so that will be y into y star. So I0 sine square alpha by alpha square, where alpha represent LA by 2, so this alpha depends on theta angle, and intensity I0 will be CA capital A into small a square. Okay, so intensity depend on this sine square alpha by alpha square, and sometimes when intensity become intensity, if it is going to be maximum, then this quantity sine square alpha by alpha square should be maximum. Okay, now this maxima and minima intensity if I want to calculate, then I have to make according to maxima minima theory, that is di by d alpha equals to 0. Now if di by d alpha equals to 0, and if you just differentiate this term, then this term will give me sine alpha into alpha cos alpha minus sine alpha. This quantity will be 0. Now if this quantity will be 0, either sine alpha equal to 0 or this will be 0. If sine alpha equals to 0, then d square I by d alpha square, this will be greater than 0. If you put the value of sine alpha equals to 0 in after d square after computing d square alpha by alpha square, we will get that this will be greater than 0. So this sine alpha equals to 0 represent the condition of minima, and if you put another part that is alpha cos alpha equal to sine alpha, this gives me alpha equal to tan alpha. So d square I by d alpha square, that will be less than 0 if alpha equal to tan alpha, and this condition gives me the condition of maxima, right? So the minima points are sine alpha equals to 0, and if sine alpha equals to 0, then the value of alpha will be m into pi, where m will be plus minus 1 plus minus 2, but uh, we are not taking into account alpha equal to 0, because for alpha equal to 0, this point gives me the central maxima, right? So for minima condition, except alpha equal to 0, I take any integer value of m, and the condition of minima will be m into alpha. So as alpha equal to a sine theta, so a sine theta equal to m lambda. So sine theta equal to m lambda by a. So that is the condition of minima. Now for m equals to 0, what are the value of m equals to 0, because I neglect the term alpha equal to 0 here. So for alpha equal to 0, this m equal to 0 means that is the central point, that is a central fringe. So the value of central fringe, alpha tends to 0, sin alpha by alpha, the value of it is 1. So this gives me the condition of maxima, that is central maxima. Okay, so what are the next I come to the value of alpha equal to tan alpha. Now to calculate those maxima point, I have to draw two curves. One is y equal to alpha, and this will be a straight line because y equal to x and m equal to 1. So the slope will be 1. So this straight line make an angle 45° with each of the axes. And another equation will be y equal to tan alpha. So the first line I have to draw y equal to alpha, and the second graph I have to draw y equal to tan alpha. Then I have to take the point of intersection to get the points. Okay, so the intensity, so the maximum points where these two curves are intersect on each other will be alpha equal to 0, alpha equal to plus minus 3 pi by 2, alpha equals to plus minus 5 pi by 2. So these points gives me the condition of maxima. Alpha equal to 0 the condition of principal maxima, central maxima, alpha equals to 0 is the first maxima, alpha equal to 5 pi by 2 will be the secondary maxima. Okay, so this is the principal maxima, I equal to I0 sine square alpha by alpha square, this will be I0. First secondary maxima will be I1 equal to I1 sine square 3 pi by 2 by 3 pi by 2 square, so 4 by 9 pi square into I0. And second secondary maxima, that is I2 equal to sine square 5 pi by 2 by pi by 2 square, 4 by 25 pi square into I0. Okay, so this gives me the conditions of different maxima that are situated. Now how can you draw this curve? See, in this picture these are the curve of tan alpha. Okay, tan alpha will be undefined when alpha equal to m pi by 2. So in the points where alpha equal to 3 pi by 2, 5 pi by 2, at those points tan alpha will be either plus maxima or minus, plus infinite or minus infinite. So undefined. Okay, so these are the curves of tan alpha, and these are the point of intersection. So at this point of intersection we get the points of principal maxima. Okay, now the distribution of intensity pattern will be, this will be the central maxima, so this will be maximum, that is I0, and the secondary maxima will be distributed in this way in the either side of this principal maxima. And these points where alpha equal to m pi, that basically represent the positions of minima points. Okay,